Welcome back. This is an Aleks training video on predicting and naming the shape of molecules with a central atom. Okay, we've done lots and lots of practice up to this point. Now we have to name something and then also give it shape, give what it looks like, 3D space. So they're going to give you an ion. Here it is iodide tetrachloride anion, -1. And they're asking for its for the shape, the word for the shape that it is, and then its angle between an iodine chlorine bond. Okay, so Lewis dot structure. Always start with Lewis dot first. Let's see. We're going to have iodine in the middle. Obviously, you've got all these chlorines, so they're going to join to the iodine. So you're going to have iodine in the middle, and you're going to have chlorine, okay, out to the sides. All right, let's find out how many total electrons we have. Chlorines have 7. Okay, so 7 times 4 is 28, and iodine also has 7. Okay. So we got 35 total ones, plus we have that this is an anion, so it's 36. All right, so we have the 35 from inside the valence plus the anion is 36. That's 18 pairs. So this is 1, 2, 3, 4. Okay. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I need 2 more. Okay, well I can't put any more around the chlorine because chlorine's stuck out on the outside. They already have an octet, so I'm going to have to put 2 more on the iodine. So let's keep them away from each other. So put 2 there and there. Okay, so that means that I've got how many groups attaching to the iodine? Well, I've got 4 bond pairs plus 2 groups of lone pairs. So I have 6 things. I have 6 ligands. I have 6 things, 6 groups attaching to it. All right, so I need something based on a 6. All right, so if I remember back to a 6, that's going to be an octahedral arrangement. Okay, I'm going to have an octahedral arrangement for a 6. So an octahedral, remember, is, if I can draw an octahedral, you're going to have something like that. Here's a central atom. I've got a east, a west, a front, a back, a straight up, and a straight down. So everything is 90 degrees. Each one of these is 90 degrees from each other if it's an octahedral. Okay. Now this is not an element. This is just a lone pair. This is not an element. That's a lone pair. Okay. This is the iodine in the inside. These are chlorines on the outside. So what is its shape? Okay, well, let me get you something to see. This is a group of all of the ligands depending upon the number of electron groups that are attached to the central atom. So starting here with 2, if you have 2 groups attached to the central atom, 2 ligands, then it would be bent. Okay, so you have 3 electron groups, so you're going to have 2 atoms, 2 ligands, plus 1 lone pair. That would be bent, like water. Then if you have 3 ligands and no lone pairs, you'll have trigonal planar. Okay, so when you have 4 groups, electron groups, but 2 of those 4 are lone pairs, you also have a bent. Okay. If you have one lone pair and 3 ligands, you're going to have trigonal pyramidal. If you have 4 ligands and no lone pairs, you're going to have tetrahedral. Okay. Now, once you start getting into 5 ligand groups, okay, 4 ligand groups would be 2, 4, 6, 8. That's the octet rule. Anything 5 and 6 here are going to be breaking the octet rule, which is okay as long as they're big atoms, big elements, like lower down on the periodic table. Okay, so if you were to have 2 ligands, but 5 groups, you're going to have linear again, where you have in the middle are all going to be your lone pairs, but then your straight up and straight down would be your ligands. That would be linear again. If you were to have this same thing with 5, where you have 3 around the middle of the equator and then 1 top and 1 bottom, but 2 of them are lone pairs, then you'll have what's called T. You can have it looks just like a T, where it's 180 degrees on one side and 90 and 90. Okay. If you have one set of lone pairs, then you're going to have what's called a seesaw or a teeter-totter, and I like that. It's one of my very favorite shapes, is a seesaw. Then if you have lone pairs top and bottom and 3 ligands, so you're having 5 groups but 3 ligands, you'll have a triangular pyramidal again. Okay, and then here's number 6. Now here's our guy. This is ours. We've got 1, 2, 3, 4, 5, 6 electron groups. 2 of them are lone pairs. That means that just these guys are going to be the only thing you see. Okay, now we already knew that this is 90, okay, and this is 90, this is 90, this is 90, because it's just north, south, east, and west. Then straight up out of the paper is a lone pair, and straight down into the paper is a lone pair. So these guys are going to be 90 degrees apart. All right, so that'll be my answer. Okay, so it's 90 degrees apart. Oh, that would be here. What's the angle? 90 degrees. And what 2-word phrase best describes its shape? Well, that's this. Okay, it's a square planar. Okay, all of these shapes are in your book, and you certainly can use them. We're in section 9.2, I think. You can certainly use them as you're doing your homework. Okay, thanks.